Hi guys, welcome to my new video. In this video, we are going to learn some theorems related with parallelogram. So, first we'll learn what is a parallelogram. Then we'll learn surfacely look at the theorems related with parallelogram and triangle. Then we will learn how to prove theorem. Then we will prove the theorems. Okay, so without further ado, let's get right into it. So, first of all, let's look what is a parallelogram. A parallelogram somewhat looks like this. Okay, so let's name it A, B, C, and D. Okay, so a parallelogram is basically a quadrilateral where its opposite side, so AB, if we look at the side AB, then its side AB is parallel with side CD or DC, and length of AB will also be equal to the length of CD. So we use this sign, arrow sign, to denote parallel lines, whereas we use this sign like a sort of cut in the line to denote the sides are equal. So this is a parallelogram, but it does not end here. The side BC is parallel with side AD, and the side BC is also equal to the side AD. So since we have two parallel lines, four parallel lines, AB parallel to CD and BC also parallel to AD, then we cannot use the same sign, so we'll use a double sign. So double arrow, and also to denote that BC is equal to AD, we use double cut. Okay, so that's basic. Let me get rid of this, and that's it. That is a parallelogram. There are many more properties of parallelogram, but for this video this much will be fine enough to cover. So now let's look at some theorems related with parallelogram. Let's look at one theorem. Let's name it theorem 1, and let's enlarge this parallelogram. Okay, so our theorem 1 states that the area of the triangles formed by a diagonal of a parallelogram is half of the area of the parallelogram. So first, let's divide this sentence into some parts. Let's divide this triangle part. The area of the triangle formed by drawing a diagonal of a parallelogram. So the triangles formed by drawing a diagonal of a parallelogram. So our diagonal is AC, and the triangles are here ABC triangle, so this triangle, and the other triangle ACD or ADC, so this triangle. So we have two triangle ADC and triangle ABC. Okay, good. Oh, and yeah, by the way, for denoting triangle we use this symbol, so it's a bit like a triangle. Let me get rid of this. Okay, so the area of triangles formed by drawing a diagonal of a parallelogram, so we find out that triangles is half of the area of the parallelogram. So is half of the area of the parallelogram. Okay, so if the area of the parallelogram is 4 centimeters square, then the area of the triangle ADC equal to area of the triangle ABC equal to 2 centimeters square. So that's basically what we need to prove, or what the theorem 1 says, and we are not gonna go directly in proving it, but first we are going to get some ideas on how to prove this. In order to prove that the triangles formed by drawing a diagonal of a parallelogram is half of the area of the parallelogram, we need to start by proving that the area of triangle ADC equal to area of triangle ABC, because if triangle ADC or triangle ABC is half of the parallelogram's area, so that's 4 centimeters square, then the area of triangle ABC is obviously gonna be 2 centimeters square, and so is the area of the triangle ADC. So we need to prove this theoretically, not this numerically. So in order to prove this theoretically, we know that if the if the two triangles are congruent, then the area of the triangles are equal. So we can prove that by using some techniques. If we prove that the area the triangle ABC is congruent to triangle ADC, then we can prove that the area of triangle ABC is equal to area of triangle ADC. And if two area of the triangles are equal, then by using some whole part axiom and some other techniques, we can, or steps, we can prove that the area of the triangle formed by drawing a diagonal of a parallelogram is half of the area of the parallelogram. Okay, so we got the concept in our brain. Now how to present it while we are doing our, let's say, homework or exam. So first of all, let me get rid of this and let's jump right into it. Okay, so first we will write, okay, let me change the ink. We will write given, and we will write what information is given to us by the question. Here the question is, we need to prove the area of the triangle formed by drawing a diagonal of a parallelogram. Okay, so we have a parallelogram and the parallelogram is ABCD, so we need to write ABCD is a parallelogram. We can use this symbol, like sort of this, to represent a parallelogram, but for now we will just write parallelogram. Okay, so we also know that AC is the diagonal of a parallelogram. So if we write a parallelogram, we don't know which parallelogram. In mathematics we need to be specific, so we can write the AC is the diagonal of parallelogram ABCD. That's it. Okay, now that we have written our given, we need to write what we need to prove. So to prove, we need to prove, we can write what is written in the theorem, or we can also simplify it by writing that the triangle formed by drawing a diagonal of a parallelogram. Okay, so let's select a triangle, maybe ABC. You can choose triangle ADC as well. So triangle ABC is half of the area of the parallelogram, so we need to prove this is half of the area of parallelogram ABCD. So that's basically what we need to prove. Okay, so we have written our given to prove, and we can directly jump in proving it, but in some questions we may need to do some constructions like this or something like this, but for now we don't need to do it. So in the other exercise we can discuss on in which case we need to do some constructions, but we have already gathered our idea and we don't need to do any construction. So we'll just skip the construction part and we'll go right into proving. So we can write like proof, and in order to prove we need to do develop some table. So let me draw a table, and drawing table makes it easier for us to know how the theorem is proven. So we will draw a table. Okay, so go ahead and draw this table, and we'll write here number and here statement, statement statement, and here reason. So okay, in number one, let's write that first of all, as I already told, in mathematics we need to be specific. So here the area of the triangles formed by drawing a diagonal. So what are the triangles? The triangle ABC and ADC, and we have got our idea that we need to prove that the triangle ABC and triangle ADC are congruent. So first of all we need to specify those triangles. So let's just write in triangles ABC and I'll just write and triangle ADC. Okay, so reason, we don't have to write any reason here, just two triangles, regular triangles, nothing more. Okay, so in triangle ABC, we can prove that the triangle ABC is congruent to triangle ADC through different axioms. Here we know that AB is equal to DC. So let's go ahead and write that AB side is equal to side DC. Okay, and we can write here side, and in the reason we can write the opposite side of parallelogram. Okay, so in number 2, we have the side BC equal to the side AD because they are the opposite side of a parallelogram. So let's go ahead and write that BC is equal to AD, and this is of course a side, and if this were to happen a angle, then we could have write here angle, but for now it's side, so let's side. Okay, and in reason 2, well, the good thing in this table is that we can write same as reason 1I. Well, so that we don't need to write repeatedly the opposite side of a parallelogram, the opposite side of parallelogram, and so on. Okay, so in number 3, now what to do? We have two side equal, but we don't have the other side equal, or we do. AC equals to AC. If you look carefully over here, the side AC belongs to the triangle ABC, and the side AC belongs to the triangle ADC, so it automatically is equal, right? So in the theorem, in the reason 3, we can write a common side. Okay, so let's go a bit down in the page. Okay, let's draw some more some more lines, and now we can write, therefore triangle ABC is congruent. So we use this sign to denote congruent triangles. Triangle ABC is congruent to triangle ADC, and we can write reason here from SSS axiom. Okay, so that's it. Okay, so we have our reason 1 completed, and we have now proved that the triangle ABC is congruent to the triangle ADC. Now that we have proved two triangles congruent, we can prove that the area of the triangles are equal. So in reason 2, we can write area of triangle ABC equals area of triangle ADC. Okay, here we can write because the triangle ABC is congruent to triangle ADC. We know that these two triangles are come from the parallelogram. So if we add the triangle ABC and triangle ADC, then we get the area of the parallelogram ABCD. So let's just write that the area of triangle ABC plus area of triangle ADC, this ADC, they make up area of parallelogram ABCD, and in the reason we can write whole part axiom. Okay, so we can just write here or 1 and or. So triangle ABC plus triangle ADC equal to parallelogram ABCD, and we know that area of triangle ABC is equal to area of triangle ADC because we have already proved it here. So we can write that triangle ABC plus triangle ABC equal to parallelogram ABCD, and simply in the reason we can write that area of triangle ABC equal to area of triangle ADC from statement 2. Okay, cool. So 2, or we know that 2 triangle ABC, because triangle ABC plus triangle ABC is 2 triangle ABC. Notice that I'm not writing area because the space is too less, and you can also not write area. So 2 triangle ABC is equal to parallelogram ABCD, and there is no reason to write here, so just leave it blank. And here if we move this 2 to the other side, then we get triangle ABC is half of parallelogram ABCD, and boom, we've proven it. So to give this a final touch, we need to write therefore, and here area of triangle ABC equals half of area of parallelogram ABCD, and nothing needs to be written in this reason part. And if we draw here, then we can also write here proved, PROVED, and that's how we need to prove it. So if we just look at this, this is how we write in our exam or in our homework paper, homework. Okay, so given and to prove and proof, and if there needs to, if we need to do some construction, we need to write here construction, but we don't need any construction over here, do we? Okay, so let me get rid of that. Proof, and that's it. Proved. We've proven our theorem 1. So let's go to theorem 2, 3 and 4. Okay, so theorem 2 states that parallelogram on the same base between same parallel lines are equal in area. So we need to prove this. So before proving it, I want you to draw a parallelogram. First of all, I want you to draw a parallelogram. So let me draw mine parallelogram. Okay, and let's name it ABCD. I just like to stick with ABCD. Okay, so parallelograms on the same base. So we have parallelogram ABCD, where AB is parallel to DC and BC is parallel to AD, and AB is equal to DC, and BC is equal to AD. But we don't need to write these signs always, because this makes our figure a bit dirtier. But let me just write that AB is parallel with DC. The reason I am doing this is because you will find out in a minute. Let's read the theorem 2. Parallelograms. So here we have parallelograms. We have S over here, so that means more than one parallelogram. Parallelograms on the same base between same parallel lines. So between same base between same parallel lines, same base and same parallel lines. So we need to assume the base. So if we want to make the base AB, then we need to draw a parallelogram touching with base AB and touching the side DC. So now what we need to prove is that the area of the parallelogram ABCD, so this area, is equal to the area of the parallelogram ABEF, so this parallelogram. Okay, so first of all, come up with the idea on how this can be achieved. Just think about it. You can write in your copy, you can pause the video and do it, and you may need to draw some construction. I'm just giving a little hint, probably like this, or anyway, you must think it about that yourself. But in this proving this theorem, you may need to draw construction. Okay, so pause the video and try it yourself. Hopefully you have found the idea on how to solve this. So let's get right into it. Okay, so before I prove this theorem, I want to say that proving a theorem, you can use some other theorems. So there are altogether 4 theorems. We are going to learn 4 theorems, and if we want to prove this theorem too, then we can use theorem 1, 3 and 4. And keep in mind that theorem 1, 3 and 4 do not need to be specific theorems. They are just number given so that it would be easy for us to study. Okay, so before proving this theorem, let's look at some other theorems. There are multiple ways to do theorem 2, and I will present two ideas. We need to draw the diagonals of parallelogram ABEF and parallelogram ABCD. Okay, we have the diagonals. So the diagonal A is the diagonal of parallelogram ABEF, and the diagonal BD is the diagonal of the parallelogram ABCD. Okay, so let's look at other theorem, theorem 3, or just another theorem given the number theorem 3. It states that the triangles standing on the same base between the same parallel lines are equal in area. So that means if I draw the figure, and you might kind of get like sort of irritated because I told you to pause the video and find out how to prove that, and actually I am presenting some new concept, but this is just a new concept, and there is another way of proving it on the old concept, like on the concept that you don't need to know the theorem 3, but I am just proving it in order to say that a thing cannot be proven, or a theorem or something cannot be proven solely or from one method only. There are multiple methods to prove it. So that is what I am trying to present here, and also trying to prove the theorem 2. So we have our triangle ABC and ABD, and if AB is parallel to DC, then the triangle ADB is parallel. The area of the triangle ADB is equal to area of the triangle ABC, and we will prove this theorem as well. But let's just take this concept and implement it on theorem 2. Okay, so our theorem 2 says the parallelogram on the same base between same parallel lines are equal in area. Okay, so on from theorem 3 we got that the area, so let me just write over here, area of triangle AEB is equal to area of triangle ABD. So area of triangle AEB is equal to area of triangle ABD, because they are standing on the same base AB and between the same parallel lines AB and FC. So from theorem 3 we got this. Okay, and we also know that triangle AEB is equal to half of parallelogram ABEF, and we also know that triangle ADB is equal to half of parallelogram ABCD. So the area of triangle ADB is equal to area of triangle AEB, so half parallelogram ABCD will be equal to half parallelogram ABEF, and if we just move this 2 over here and 2 over here, then we get 2 parallelogram, no, let's not do this a long way. If we move this 2 over here, then we get that parallelogram ABCD is equal to 2 times half parallelogram ABEF, and this 2 and 2 are crossed, and we get the area of parallelogram ABCD equal to area of parallelogram ABEF. So that's it. We just proved that the parallelograms on the same base between same parallel lines are equal in area. Now I gave you the concept idea, and you need to draw the format given and writing to prove and number statement, number reason, and you need to do that. That is in your exam. Okay, so that is concept 1, but there is another concept also, and rather easy one I feel it, to solve this problem, and I am going to share it with you as well. So let me just get rid of this, and okay, so we don't need to draw this. There is such an easy concept that you might say that, oh, why didn't I think of it before? Okay, so first of all, let me erase this diagonal and let me draw a straight line. A straight line joining the point D or the point E. It really doesn't matter which point. So let me just choose point D. and that will be perpendicular to the line AB. Okay, so we know that the area of a parallelogram, we know that it is equal to base, BASE, times height, HEIGST. Is this the spelling of height? We'll just write the correct spelling. So base into height. So base we have AB, and height we have A B C D E F G. Okay, DG. Okay, so height we have DG. So area of parallelogram. So if this is a AB, right? Okay, if this is a parallelogram ABCD, then this is correct. And if the parallelogram is ABEF, then this is also correct. We have the same base and we have the same height DZ. So we can prove that the area of parallelogram ABEF is equal to area of parallelogram ABCD. But proving it with theorem 3 will be a bit more long, and proving it from this concept will be a bit easy. So this is another way to prove that the parallelograms on the same base between same parallel lines are equal in area. And you might say that the height dz can be variable, meaning it is different for parallelogram ABEF and different for ABCD. But if you have not noticed, the it is standing between two parallel lines AB and CF. So if I draw here two parallel lines, and if I draw a perpendicular here, name it AB, then if I draw another perpendicular here, CD, then these two will be equal in length. Why? Because they are standing between same parallel lines. So how many you can draw parallel perpendicular lines here, but they will all be equal in length. So and since we have parallelogram between same parallel lines, the height will be equal. Okay, I hope you are clear, and hopefully you can present it in the format I told you to. Let's get into theorem 3. Okay, the triangles standing on the same base between the same parallel lines are equal in area. Okay, so you don't proving this theorem also we have two method or many method, but I know of two, and it is quite easy. You can use the idea that we used to prove the theorem 2, that is area of by using the base into height, and we proved that the area of parallelogram ABCD and area of parallelogram ABEF are equal. You can also use that we know that the area of triangle is half into base into height. You can also use this concept to show that the bases are same, and if the heights are same, then the triangle are equal. Just the area of triangles are equal. Pause the video and write yourself, and you also may need to draw some construction. Okay, I think you have got it, the idea. Okay, so here the base is AB and the height we need to construct it. Okay, so if I just construct this like this, and this be perpendicular, and name it E, then we know that the height AE is same for triangle ABD and same for triangle ABC, and so the height is also same and the base is also same. So if this if we write it according to the sides, half into AB into height is AE, and this will be equal to triangle ABD. Well, and this is also equal to the triangle ABD is also equal to triangle ABC, because the area of triangle ABC is half into AB into height. Well, the height is AE, so that's it. You can prove that the triangles standing on the same base between the same parallel lines are equal in area. But there is another method also to solve this, and I am gonna share it with you that as well. So first of all, just figure it out by pausing the video what might be the idea, and if you got it, then that's very good. Okay, so just pause the video and try it yourself. Okay, hopefully you have got the idea. So first of all, let me erase this perpendicular. Okay, as much as I hate to say it, you may hate to hear it, but to prove this, you need to have the idea of theorem 4. And theorem 4 states that the area of triangle is equal to the half of the area of parallelogram standing on the same base between the same parallel lines. So first of all, let me write the name. ABCD is a parallelogram and ABE is a triangle. They are standing on the same base AB between the same parallel lines AB and EC. Okay, so here according to this theorem, it says that the area of triangle, that is triangle AEB, is half of the area of parallelogram, which is ABCD, standing on the same base AB between the same parallel lines EC. Well, we will prove this later, but let's just get this concept and move into theorem 3. And you might have already figured out by seeing the theorem 4. Here we have triangle ABD and triangle ABC, but we do not have any parallelogram, so you might need to draw it. So we can construct a parallelogram so that can be parallel with the side BC. Okay, so the side BC parallel. So if I just take this out like this and just draw this parallel to the side BC, then there we go, we have a parallelogram, which is CBO, right, name. So ABCD, maybe here E and here F. Okay, so we have a parallelogram BCEF. So we have a parallelogram and we have triangles. But here you may have noticed that we cannot use theorem 4 because they are not standing on the same base between same parallel lines. So let me just erase this and draw the correct construction. The correct construction should be something like this. It should be here, right, because they need to be standing on the same base and between the same parallel lines. Okay, so the same parallel lines and the same base, and let's name this E. So we have a parallelogram ABCE. So ABCE is a parallelogram, and if you look closely, we have a diagonal AC that bisects the parallelogram ABCE. Okay, so you might you can pause the video and think it again on how can this be proved. Okay, so I think you have paused the video and think about it. Hopefully you have got the idea. Okay, so we need to use now two theorem here. So here the triangle ACB here is half of the parallelogram ABCE. Why? Because the diagonal bisects the parallelogram. So let me just write it over here. The triangle ABC is equal to half of parallelogram ABCE. This idea we derive from theorem 1. Okay, so the another thing is that we derive from theorem 4 is that the triangle ABD, if we look at this triangle ABD, it is standing on this base AB between the same parallel line EC and AB, as that the parallelogram ABCE. The parallelogram ABCE is also standing on the same base between the same parallel lines, and the triangle ABD is also standing on the same base between the same parallel lines. So our theorem 4 says that the area of triangle is equal to half of the area of parallelogram. Area of triangle, the triangle is this triangle ABD is equal to half of the area of a parallelogram. The parallelogram is ABCE standing on the same base. The same base is AB between the same parallel lines. The same parallel lines is AB and EC. So we can say that triangle ABD, the area of triangle ABD is half of the area of parallelogram ABCE. Okay, so now we got that triangle ABC is equal to half of area of parallelogram ABCE, and the area of triangle ABD is equal to half of the parallelogram ABC, not DE, ABCE. Okay, so we got that half area ABCE is half area ABC, and if we just equate these two, we can get that triangle ABC is equal to triangle ABD, because half area because the area of triangle ABC is also half area of ABCE, and triangle ABD, the area of triangle ABD is also half of ABCE. So indirectly triangle ABC, the area of triangle ABC is equal to triangle ABD. So we have proved the theorem 3, which states that the triangles standing on the same base between same parallel lines are equal in area. Okay, so you might want to do this formally by drawing tables, but I'm not gonna do it right now. Okay, so let's go to theorem 4. Let's see what this theorem 4 says. The area of triangle, the triangle is obviously it's gonna be triangle ABE. This triangle is equal to the half of the area of parallelogram ABCD standing on the same base AB between the same parallel lines AB and CE. So this is what we need to prove. You can pause the video and try it yourself, and since we have already discussed the other 3 theorems, you can derive those ideas and try to solve this, or you can think of them in another idea as well, differently. Okay, so pause the video and try it. Okay, so you might have got the gist of how to solve this. First let's read the theorem. The area of triangle here ABE is equal to half of the area of the parallelogram ABCD standing on the same base between same parallel lines. First let me just write this in letter form. The area of in the form of triangle and parallelogram symbol, half parallelogram ABCD. So that is basically what the theorem says. The area of triangle here ABE is equal to half of the area of parallelogram standing on same base between the same parallel lines. So how do we prove it? So there are many ways to prove this, where I will be teaching you 2 ideas or techniques. Okay, so first of all is the technique that we proved theorem 3 and theorem 2. So the idea is similar. First we can construct a perpendicular, but that didn't become okay. So first we need to construct a perpendicular. Let's name it let's say ABCD F and G, and if we write the area of our triangle, then the area of triangle ABE is equal to half into base into height, where our base is AB and our height is EG. So if we want to find the area of parallelogram ABCD, then that will be base here AB into height, that is FG. So if you compare these two, then we have AB, FG just here half. So we can just prove that area of triangle ABE is half of area of parallelogram ABCD by writing half into AB into and this is E actually, half into AB into EZ. So AB into EZ is the parallelogram ABC. ABCD. So that's it, we have proven it. So this is a very easy method, but there is also another method which I will be sharing with you. So first of all, let me get rid of this, and just try to think it yourself on how this can be solved with another method. Till then I will just clear this. Okay, hopefully you have come up with an idea. Let's check it. First, let's see what we need to prove. The area of triangle ABE is equal to half of the area of parallelogram ABCD. Okay, so let's draw a construction. The BF will be parallel to AE, and this will be equal to this, so there will get a parallelogram. And if you look closely, we have a diagonal EB. So the diagonal of a parallelogram bisects the parallelogram. We have learned about it in the theorem 1. So if we represent it over here, then we can say that the area of triangle ABE will be half of the area of parallelogram, and the area of parallelogram is ABFE, the name of the parallelogram ABFE. Okay, so from the theorem, I don't know which, it says that the parallelogram standing on the same base here, AB, between the same parallel lines AB and CE, will be equal in area. So let's just write over here that parallelogram ABFE standing on the base AB between the parallel line AB and EC will be equal to the parallelogram, this a bit like rectangle, will be equal to the parallelogram ABCD standing on the same base AB between the same parallel lines AB and CE. Okay, so if we just replace this ABFE with ABCD, then we get tada, half into parallelogram ABCD. There it's, we have proven it. Now your job is to just prove it formally by drawing the number statement, number reason table and given, and to proof, and the construction also. Okay, that's all for today. So in this video we learned what is a parallelogram and how to prove some theorems, and we learned 4 theorem relating to the area of parallelogram and area of triangle. So that's all for today. Meet you in the next video, where we will discuss about some exercise related with area of parallelogram and area of triangle.